So we're trying to start a discussion again on the same topic. Just take one more question here from Ruthar Mathur's book. So one question we have done, and we'll try to proceed ahead. If you're not able to solve a question for two times, and then we'll just go ahead, obviously. Okay, we'll come back to the question. It's very obvious with us, right? We'll come back again. Three attempts will make for any question. So let us. So the other question, what we are having right now. So the book is same exploration of Olympiad combinatorics, and I'm just going for question number problem. So it is better for me. I want to put the question is very big question, so I'll not put it here. Better I'll just go for solution number. Okay, so what we'll try to do. Okay, what we'll try to do. We'll try to write the problem actually. That will be good for us. In the first one, we have not written. So let me write the problem. Statement of the problem is important for solving it. Can one make can one make can one make change can one make change of a 25 rupee bill? Can one make change of a 25 rupee bill using 10 coins? Using 10 coins, each having a value of 1, 3 or 5 rupees. So let us start the solution for this. So the question says that can one make change of a 25 rupee bill using 10 coins, each having value of 1, 3 or 5 rupees? Okay. So the coin values they are giving. Let me just understand how to proceed for this question. Okay. So let us try to understand what can be done for doing this part of the question. Okay. Can one make change of a 25 rupee bill using 10 coins, each having a value of 135 rupees? So we have here uh, so we have a 25 rupee bill is there with us. Okay, we have 25 rupee bill. Can one make change of a 25 rupee bill using 10 coins? We have 25 rupee bill with us. Now we have to distribute it into 10 coins. 10 coins, and here we should have 1, 3 and 5 rupee coins, rupee in denomination we can have. Okay, so 10 coins we want, we have to think about it how to keep it. Obviously we just have can one make change, so it is possible or not. Firstly we have to just check it whether it is possible. So 5 rupee coin I have here. Can one make change of 25 rupee bill using 10 coins? So the iterations 1 x y z we can take, and the total will be 25. So we can say, let us say, let denominations, numbers basically, let quantities quantities of 1, 3 and 5 rupee coins be. So let us take the case here, be x, y and z. So we can say therefore x plus 3y plus 5z is equal to 25, and we have to find the value of x, y and z. Okay, so what we can do, that we have to think. So 3, does 3 is having any type of numbers which are 15? We can 3 5 5 coins we can take for 3. So 10 will be left, and in 10 we can say 5 rupee coin. If you take 1, so it will be a bit not okay, because you have to see the combination possible for this. Okay, so if I'm just thinking in the very raw data, so 3 3 8 times is not possible. If you go for 3 8 times 24 and 1, so it is compulsory to here or not, we don't know. Can one make change of a 25 rupee bill using 10 coins, each having a value of this now? So each having a value, each having a value, either it is having 1, 3 or 5. So that is also an important part. So 5 at least, if 1 we are taking, so 20, for 20 we have to think about, and 5, 6, and it will not work out whenever we are taking for 5, 5, 10, 5 and 5 and 10. Already it is not possible. 16, 17, 18, 19. So let us say 3 5 rupee 3 3 value coin with what we are having is 5. It is 15. 15 plus 10 will be 25, but 5 rupee coin is not there in that, and that is a problem. If you take mm, 5 1 5 1 3, it will be obviously 20, and it is 17 to 7. It is a very big value. 17, 18, 19 is only coming up. We have to bring 25. Sorry, 10 coins only we need here. Okay, be very careful. 10 coins. Here, one more condition is given, that x plus y plus z is equal to 10. Okay, that is also the case we need to understand. But we have two equations, but the problem is we have three variables with us. Okay, that is the case. Uh, that is the case actually. We have three variables, two equations, so we can't solve it directly. We have to think some other way around. So let us take some time to think. You're just going with the see. Our purpose is to try the question at least two times, and at least three times. I can say three attempts I'll make for the same question. And if it is done, it is well and good. If it is not done, then I can say that yeah, I have to refer whatever the other hints etc. is given, but I'll not try to use it. That is the main thing. So we have three variables. Can we make to two variables somehow? Is it possible or three? So let us say x is uh, some values we have to take for 3 and 5 also. Otherwise, it is not possible. So 5, if you're taking 5 and 5 and 5 will work out. If 5 rupee coin is not there, it is very easy for us to solve this question. Okay. Not sorry, not easy because total should be 25 only and 1 1. Okay. So 8 and 8 16 will come up. So it's not possible. So only 10 coins we are having. So let us say 2 coins we're taking for 5. Then let's say 4 coins we're taking for 5. Okay. 4 coins we're taking for 5 is 20 and 20 plus 5 20 4 coins no 4 coins we are taking 4 coins we are taking for 5 3 coins let us say we are taking for 5 so it's 15 3 coins 6 no it is not possible if you're taking for 1 coin here so from 20 you think 9 coins 9 8 3 fours 4 5 not possible. So it is a very good question. We have at least tried one attempt. Attempt number one we have done here. This is attempt number one. I'll just write attempt also. Well, let me try for some more time, and then I'll just say that yeah, it's not solvable from my end. Yeah, in the first go. So this is the a bit not easy way, but we'll try with this obviously. Okay. So it is not considered to be an easy way. I'm not saying. So it is very possible that anyone done, but I want to improve myself. Okay. I want to work on my things. Then obviously for that I have to work like this only. There can be many students, I understand. There can be many students who can solve this question directly in very short time. But right now it is not coming to my mind. So right now I will try. Na? It is my journey and my improvement. Okay, for that I'm just doing this work instead of going in a very secretive manner. I'll just demonstrating myself. Yeah, I'm not able to solve this question at the moment, but I'll try to improve from here. That is this book is good. An exploration of Olympiad combinatorics. By Rushil Mathur is I am a gold medalist. So I think yeah, you have to think like this. What is not possible? One if you're taking it's not possible. I guess no. Y1 Z1 it is 8 and 8 and Y1 Z1 8 is there. So it is non-val zero value obviously. So 8. So if you're taking 1 so it should be 8 plus 8 16 will come up. It's not possible. So what is not possible? Let us just write out at least. We can try for some time, let me try this. This is the rough work I'll just do here. Okay. I'll do the rough work here. So 1, 8 plus 1 plus 1. It is not possible. Why? Because it is 3 plus 5, 8. 8 plus 8, 16. So it is, we can say for here x, y, z. 8, 1, 1 is not possible. Now let us go for 7. 7. So 3 is there. 7, 2, 1. Let us try. 7, 2, 6 plus 1, 5. So this is still, I think, let me just check it. 7, 6, and it will be 13. No, it's not possible. Okay. And let us go for 6 now, or we can just have the iteration here. 7, 1, 2. So it is 10, 3, 7, 20. It's not possible. Okay, we'll just, a good method is there. So now let us go for 6. 4 is left, the 2, 2 obviously. So it is 6, it's 10. So it's 12. Total is 22, which is not possible. So let us go for 5. Let me just 3, 3, 2. I'm just trying here. So it is 5, 9, and 10. So this is obviously 15 plus 9 is 24. It's very, very close, but not possible. Now let me just try the other way around, 2 and 3. So this is 15, 6, and 5. So it is not possible because it is going for. So the question is asking, can one make a change of using? So can I make it? Let me just try this, and I'll just say yes or no. Then obviously, right? By making the iteration is not a correct way, but there can be some other way around. Right now, one method is coming to my mind. I'm just trying that. I don't say I'm not saying that yeah this is the final method. Okay, 6, 5, 15. So it is already 26. That is not correct. So 2, 3, 3, 2 we have tried. Okay, 2, 3, 3, 2 both we have tried. So let us go for 4. Now I don't think 4 will work out here. 4, I don't think so. 4, because we have, let us say we have 6 left. So let me just go for 5 here. 15 plus 1, that is 5. 24 is not work out. So 4 is still there. Let me just go with some other way around. Okay, some other way around means 4. You can say 5 and 1 we have taken. So 4 and 2 we can take. 4, 2 we can take. So it will be 3 4 12. 4 and 2, 10. It is very, very clear that is 22 and 26 is not clear. I think it's not possible. Let me try this. 4 and 3, 3 if you're trying. So 3, 3, 9, 15. This we are 3, 3, 3 we are trying. So again it is 13 is coming up. 13, so to 28 is not possible. So for 2, 4 we can try. 20 already we are getting, and 6, 4. It is 30, so not okay, I guess. So, as per my understanding, the answer is no for this particular question. If I'm wrong, I'll just try to understand what is possible. Okay, can we make a? Yeah, let me just go ahead. This is only the first try I've just made here. I have just tried the cases. Can one make change of 25 rupees bill using 10 coins? each having a value of 1, 3 or 5. So doesn't seem like, let me just check it. 197. If it is wrong, obviously I'll try to understand what is the actual logic here. Okay. So let's learn it. What was the missing part from my end? Okay. Better, I have tried it. Let me just try for some more time as per the, because whatever is given here in the book by the author. So what is more possible here? 8, if you go for 8, it is not possible. So 9, obviously not possible. So no is the answer for mine. Let me just cross verify. It looks to be no for mine. If I'm wrong in this case, then obviously I'll just try to understand what is the. So no looks to be my answer. Let me just cross verify the things. Okay, let me just see it. If it is wrong, I'll just try to understand what is the logic here. Okay, 2 times I've thought to try, but I have solved it. That's why I'm going for the now hints or whether it's correct or not. But if it's not solved, I'll just try for 3 times at least for the problem. Okay. If I do, let us say I don't have any idea about it, I'll try it 3 times. Okay. So uh, can one make? So let me just check it. Hint is 197. Page number one. This hint is I think 197 they have given. 197. Very good way to write hints also is very good. 197. Try this out. You should find that you are able to do it with 9 coins or 11 coins. But it doesn't seem possible to do with 10 coins. Okay. Yeah, it's very, very clear. And then 493. 493. 493 is the ending one, you can say. 493. What is the common to each term? What is the common to each of 135? Obviously, there is no common here, right? I can say. Zero common. 241. It's a very good way to write a book. 241 because the jumbling part. Think of odd and even numbers. Okay. 72. So we've thought all the odd and even numbers. 72. You're adding 10 odd numbers, the sum cannot be odd. You're adding 10 odd numbers, the sum cannot be odd. Okay. There is a very good logic. If you're adding 10 odd numbers, let us say 3. Okay. There's a very good logic again. The sum of 10 odd numbers, you're adding 10 odd numbers, the sum. So answer is correct here. Okay. Answer is correct from my end. So I'm happy with this. Yeah. Thank you. Yeah. So obviously the logic given are good. You're adding 10 odd numbers, the sum cannot be odd. So if you're adding 10 odd numbers, if you're adding any 10 odd numbers, obviously the sum cannot be odd because 3 times 30, 40, 50. Yeah, this looks to be good. Yeah, that's correct. Two questions we have tried and we have sorted them out. We have solved them out. So let me just mark it in the book that I have solved it out. There are two questions which I already solved it out. So I'll just problem number one I have solved. Problem number three I have solved. And it is from the book An Exploration of Olympiad Combinatorics, 1.2 problems. Problem one, problem three of 1.1 introduction. The basic problems. It is not a very difficult problem, but still, yeah. And I'll just try, let us say, any problem I'm stuck with. So the thumb rule will be, there will be some thumb rule here. Let us say the method, what I'm just trying here. After solving, there are two rules here only. There are only basic two rules for this particular videos. One rule is, if solved, I will check solution or hint, and if incorrect, I will understand and solve again. Second rule can be, if not able to solve, then better I will try for three times. Okay, three times. Okay, I'll try for three times. Then any hint or solution I can refer. I can refer. So let me just write properly. It is not good way to write. Rules for videos. Rules for videos. Random selection. It is a random selection I'm doing for the theory. Right now, it is not completely random, but okay, I can just assume that it is a random part. If solved, check solution. If solved, check solution or hint. If correct, good. If not, resolve. Okay, resolve will do. Resolve. Second, as I already mentioned, if unable to solve, if unable to solve in three separate attempts, separate is very important, separate attempts. Separate here means separate means gap, right? Means video gap can be there, video gap or etc. Still unable to solve, I'll just go for still not able to solve, not able to solve, better go for hint or solution, and post understanding it, resolve. So these are the rules for this particular video. It's a very good way actually, not very easy actually, right? So I'll just stop the discussion here. This was again a good problem, and answer was correct because the basic problems are there. As already mentioned by Rochelle, in the start he has taken basic problems. Okay. My initial understanding of the field was based on the okay. In the introduction part, these are the basic problems. The first five require nothing but common sense and very elementary mathematics. Slightly more tricky and will put your logical skills to the test. Problems become tricky and require deep thought, but their solutions only need elementary math. Hence, I've been added to the problem. Okay, that's a good way. So these are elementary problems. They're not difficult problems right now. Okay, I'll just wind up the session on this. But